I was going to talk about centralization in the ownership of IP blocks. I'm, from the internet, I'm here to help, and my idea of being helpful is generally to complain about things. I mean, to point out interesting findings, such as that RIPE NCC actually is a redundant acronym, since Réseau IP Européen translates to European IP networks, so we have the European IP Networks Network Coordination Center. Or that this particular map that you've seen before is a lie, which kind of gets me to the topic that I'm going to talk about. But before I do that, there's one more thing that you really need to know about me, which is that I have no idea what I'm doing. I work at Akamai as an information security architect. As the great George Costanza said, I always wanted to pretend to be an architect, right? But that is information security. That is not networking. So my colleagues from Akamai here probably are like, what is Jan doing up there? He doesn't do networking. And that is oftentimes what I try to do. I try to throw myself into the uncomfortable situation and talk to people I don't normally talk to. So you get a little bit of an outsider's view here at RIPE, where you all have a lot more expertise than me. So keep that in mind when you're asking questions and saying, like, why didn't he just? And it turns out the answer is, I don't know what I'm doing. Anyway, so let's get started. The year is 2035, the year of Linux on the desktop. This one's going to be it, right? IPv6 is next. We're going to get there as well, I promise you. And of course, Amazon has just bought the last available /8, 255.0.0/8, and now owns all IPv4 space. How did we get here? Well, I'm going to suggest that 2035 is perhaps even too far in the future. If you've looked around at Amazon, you'll find that they are already using internally the 240 network, Class E, for internal routing, right? So that's going to be great fun when at some point we decide, oh, we're actually going to be using this network. And then Amazon said, like, well, you're going to break all of EC2 if you start announcing this somewhere else. So it'll be fun. I actually tend to think that what the future really wants is probably more IPv6, not IPv4. But as I said, maybe we'll get there by 2034. So how did we get there? We started out and we were told that IANA assigns IP space to the regional internet registries, right? But of course, some people early on got a gift from John Postel, the original IANA. They got their own /8 at the beginning, right? And some organizations got also additional IP space. So the distribution was not completely fair, really. If we're looking at IP space just purely by IP, then we can see like the division of space that we have here. The reserved one includes the multicast and the Class E, etc., as well as the other reserved networks. So if we take those out and just look at available IP space, then we roughly see how IPv4 is allocated to the rears like so, which is not quite even. Just for kicks, comparison in IPv6 space is a little bit more even. IPv6 is a lot more boring in this regard. I'm just throwing it up here as an example. But yeah, so IPv4 space, we started running out, and then they were being traded, right, and reallocated. So blocks were given from one rear to the next one. They're being reassigned, reallocated, etc. So things are moving around. And people started buying IP space, right? So you can actually buy IP space, which comes in really handy if you happen to have a spare /9 lying around and want to make some money. So you can actually sell that IP space. And to my friends from Amazon here in the audience, I'm just riffing on you. It's, nothing personal. There are other companies that do the same thing, right? Google bought also plenty of IP space, and other companies do as well. But so you see that, like, IP space is being traded, being sold, etc. And of course, really cool thing, AWS at some point decided, you know what, these are worth some money. We can actually, charge people for that. And I started this whole talk basically by stumbling across the AWS IP ranges and going like, wait a second, that's a lot of IPs for just one organization to have, right? I mean, that's a fair bit of number of space that is available. And that's just AWS, that they're just saying that these are the ones that we're using here. which, by the way, by their logic of 5 cents or half a cent per hour per IP, adds up to a net value of $6.4 billion, effectively, given that IP space. So it's not too shabby. Anyway, so like, again, IP space is being traded and traded and traded. And I was thinking to myself, wait a second, how do we actually know who currently owns what IP space? Now, in theory, we know that we can find out this information, right? We have the means for this. But how can we look at this comprehensively? Can we find out on a larger scale which different organizations own which particular parts of the IP space? And so I went like, I know, I'm going to use whois. And you can tell that I already told you I don't know what I'm doing, right? Because whois is great. Whois is neat because you can just look at this, and as a human, you're like, oh, yeah, I can make sense of this. This is great. But whois uses different formats depending where you end up on. It's all free text. And so after a while of processing this at larger scale, you just think to yourself, wait a second, this is not going to work out so well. So maybe whois is not the right approach to this. So you say, like, wait a second, I know, I'm going to use the real statistics that they're publishing so nicely on the different FTP sites or HTTPS sites nowadays. And this is what that looks like. And that is really helpful. So you have this file that tells you which IPs start out with, and then the count of IPs given for that particular assignment, including even some geolocation information. And that is really useful, and it's great. But it doesn't tell me who the IP block is assigned to in this case, right? So all I know is like, oh, there are these allocations, but I don't know who it is assigned to. So like, I know, I'm going to use RDEP, because RDEP is defined in the RFCs. So many RFCs. And it's using JSON, so I can actually process this a lot better, right? And this is kind of what that looks like. And that is really useful. That is good information. You've got, nicely structured data there with some of the information that we might be looking for. And so I went ahead and did the obvious thing. As Tobias said, people do dumb things sometimes when they're doing their research, and that's kind of what I did. I was like, you know what? I'm going to start at 000 and go through all the IP space and hit RDEP for that. Basically going like, okay, well, I'm not going to hit every IP address, don't want to do the 4 billion lookups, but I can hit the first one, see what the CIDR is, then jump to the next one and move on from there. And so the problem is, if you are dealing with multiple ways of looking at information, and if you're trying to look at sources of truth, and I'm sure all of you know this, like if you've ever looked at your inventory database or something like that, assets you have, you know that there's a set of things that you have in the database. And then you have the set of things that you kind of know should be there. And then you have the set of things that you're actually seeing out there. And those three things at most intersect. They're not congruent. And that is a problem I've seen many, many times. So it basically means that, yeah, we have a three-body problem right here. So back to RDEP. Yeah, that's the thing about RDEP. RDEP is great, but you run into a couple of things. Sometimes you get a redirect to the other RDEP server. Sometimes there's data in there. Sometimes there isn't data. Okay, you can deal with that. Redirects, of course, mean that sometimes you have redirect loops between the different RDEP servers. So that's an issue. RDEP doesn't include the AS information that I might be looking for, but whois has that information. So I have to, mingle those again. Afrinic has API limits, but they won't tell you what they are. I asked them, they said, we're not going to tell you. I said, okay, so I hit them, I get a 429 back, which is good. But there is no retry after, so I have to guess. The Brazilian RDEP server has an API limit, and they tell you what it is. They tell me 1 request for 20 seconds. After that, you get a 403, and you're on their shit list for a long time. So you can't do this, as conveniently, so you have to rotate IPs, to source IPs, and get the information that way, which isn't in their spirit either. And then you have all sorts of other issues that come after that, right? So like RDEP is wonderful, has a lot of useful information, but at the end of the day, it's the same kind of garbage in, garbage out that whois is, only structured in JSON, which, is progress. It's getting a little bit better. Anyway, so, and yes, this actually now says my hovercraft is full of eels, for those of you who know MentiPython. Because this is how I feel when I'm either looking at this data or I'm in a meeting like this, which I normally tend to avoid. But so now I have this data and I'm starting to analyze it and look at it. And so it's like, okay, so let's see, whose CIDR is it anyway? So I collected all this information and I looked at like how many CIDRs are allocated for the given countries. And I came up with 238 countries and roughly 300,000 different allocations. Well, now, countries is, of course, relative, right? The UN counts something like 196 or something like that. We have over 300 CCTLDs, but all right, 238 countries, ISO 3166, two-letter codes anyway. So just by counting how many CIDRs are allocated, these are the top 10. So I found that Russia leads this, has about 17,000 CIDRs, Germany is second, Brazil is third, and so on and so on. But that is just how many CIDRs are allocated. And that could be a /32, that could be a /23, this could be a /8. So it's not really meaningful information, right? It just tells you how many there are. So I said, okay, let's go for IPs, counting who has most of these IPs actually. And so you find that the US and China are the first two with quite a bit of them, and then the rest of the top 10 show up like this approximately. But notice that the US over here with 1.6 billion IPs covers about 43% of all available IP space. The top 10 account for 75% of all IP space, and the top 2 for over 50% of the IP space. So that's, again, not evenly distributed across the different markets. I broke this down by regional registry, but first IPv6, a lot less interesting because we have so many of those addresses, right? The only interesting thing here is I found that there are some countries that don't have any IPv6 allocation. So the Central African Republic and Eritrea over here, or North Korea. Then we have Kosovo, Western Sahara, Jan Mayen up there, Falkland Islands or the Malvinas for los Argentinos, and the French and Arctic territories. Okay, those are not so surprising, but there are some countries that don't have any IPv6 space, apparently. Anyway, so for Afrinic, it looks like this. And now think back to the original map that I showed you where I was saying this is a lie. Afrinic apparently hands out IPs, or at least has IP allocations for observed 127 countries. The first three are South Africa, Egypt, and Morocco. And then the remaining top 10 still all reside within Africa. And I'm going through this fairly quickly. Those slides will be available. I'll put this up on the blog later on. You can dive into this on your own time. But again, you see centralization there, where a certain number of allocations are concentrated in certain markets. For Afrinic, this does not even completely overlap with the expected population charts or even economy sizes, which we will see in some other markets where this aligns a little bit more. Like APNIC, not surprisingly, covers a lot of Asia. China, not surprisingly, will be one of the top players, the first one, and then Japan, and here are the other ones as the top 10. There again, the top 3 account for 75% of all the IP space that APNIC has. Aaron, obviously concentrated in the US. Interesting thing there, whoop, let me go back. The US covers 95.4% of all of Aaron space, covers 36% of all IP space. LACNIC is a little bit more concentrated in its assigned market, so to speak. But there again, top 3 account for the majority. RIPE takes the first place with 164 countries, which is quite a lot, more than just Europe, as you might expect. But at least the top 10 stay within there, approximately. All right, I then looked at what types of IP space are they actually, right? We have different allocation types. And of course, each rear uses a different kind of string for this because the RFC says type is a string. Okay, cool. Now anybody can just pick their string. So Afrinic uses 7 different types, Aaron 4 types, Apnic 5 types, Lacnic, I couldn't find documentation, but I found 5 observed. Ripe has 11, but I found only 7 in the wild. So again, you have this really diverse set of data. Breaking it down looks like so. It's like, okay. And this over here is from Apnic. That is like, to give the distinction between what these different things might mean. But different things mean different things to different rears. So it's difficult to view this and say, like, this is this and this is that, because it might be depending on type. So for Afrinic, we see these over here. And what I really care about is not so much the allocations to local registries, but more the allocations to the end user, right? Like, this is kind of what I care about. And so for Afrinic, those are assigned PA and assigned PI. So we can only focus on those for this particular aspect. APNIC has these distributions and uses assigned non-portable for end users officially. And if you're wondering why there's such a large number of unknowns, it's because, well, JPNIC RDOP sets the type to null, literally null, not the string null, but null. So that's not helpful. Aaron uses assignment for end users, although, of course, sometimes, going back, there's lag here. There. There we go. Sometimes the direct allocation is also an end user, because now we have to decide what actually is an ISP, what is a local internet registry. Is Amazon one of those, perhaps? Right? Because you could argue Amazon uses EC2 or AWS. There are other people there, so it reallocates things. Is a bank that uses IP space for its ATM network something that reallocates things? From my perspective, they are really just still that same organization, so I care about them as well. Lacnic uses assigned and reassigned over there, and is in the enviable position of having unallocated blocks in this case, show up like so. And Ripe NCC uses these types. But we also have legacy. Legacy, of course, again, is another type that may or may not be end users. I also looked at the slash sizes. So like, what is the most common allocation that we find? /24, not surprisingly, takes the lead over there. People tell me that pie charts are stupid, so I should use a Pareto chart. So here we go, same distribution. /24 is the big one. Something that's interesting is there's a large number of /32 assignments that we have, but of course we also have a bunch of /8 still. Lacnic is the only one that's an outlier, with a /22 being the most common assignment, which I thought was interesting. And by comparison, IPv6 looks like so. And hey, /24 is also the same most popular allocation for IPv6. Of course, that's like 2 dazillion IPs versus 256, but they share that in common. Anyway, so then I went to net names. I was like, okay, now let's try to find out who they actually are, these different networks, these different allocations. And net names look like so. And then I went like, okay, now I can count them by IP just instead of just frequency. And I have to somehow map these strings to the actual organizations, which isn't easy to do necessarily, because that data is or is not in RDAP. That's like Schrödinger's data that we have there. We don't know. But you can correlate to some degree. You can also identify AS numbers correlated to the different networks that you have. And again, you'll notice that we have a many-to-many mapping there, right? We have multiple AS, multiple net names, multiple identities. And of course, different organizations show up multiple times because they still are the same entity, but they have different identifiers. And if you want to correlate that, you have to actually know that that Level 3 and CenturyLink are the same company nowadays, right? Companies purchase each other and take over IP space, so it's not easy to look at this. I found about 63 distinct AS. If you just go by AS count, it looks like so. Again, these are assigned to these different companies. Something to note, there actually is a Stark Industry Solutions, like Stark Industries, like Iron Man, his company. There's apparently a British VPS provider that uses that name. All right, top AS by IP count. Again, looks like so. You break that down, and then you merge all of these things. You take the net names, you take the top IP count, you take the AS data set, and eventually you just have to do it manually for the most part. And so what I then came up with is basically the top organizations as combined by IP count look like so. DoD takes the cake, not surprisingly. Then we have Amazon, China Telecom, AT&T, Verizon, etc. As chunks of all IP space, it's DoD with 8.9, Amazon with 4.21, and so on. What's interesting here to me is that there's two companies that are different from the others. All the other ones, except for the DoD, right? All the other ones are telecoms. All the other ones are ISPs, telecom providers. Amazon and Microsoft are the only ones that are not. And they control a sizable chunk of IP space. Anyway, so rushing through this, whose CIDR is it? It's really hard to tell. Distinguishing between the end user and what becomes an ISP or an LIR is really difficult to make that call. There are a lot of inconsistencies in the rear definitions across the rears. So that again makes it difficult to get a global view of this data. There's inconsistent data in RDAP, looking up information. Sometimes you get back the first name of the person who is the contact. Sometimes you get the company name. And so it's difficult to then correlate that. The rears seem to be a lot less regional than you might initially expect based on the trading of the IP blocks. About 30% of all IPs appear to be managed by just 13 organizations, which for a global internet is, a different thing. It's, less distributed than we might like. The DoD still controls over 8% of all IPs, which is great fun because you may remember that a few years ago, all of a sudden they started to announce this IP space that they hadn't previously announced, like the 11/8, and half the internet lost its shit because they're like, crap, you're breaking me because I'm hogging your IP space internally. As I mentioned earlier, not a good idea to do that. Of course, those are still being announced nowadays. So Amazon and Microsoft take the two as non-ISPs, the two top spots there. And IPv6 is a lot more boring. And I think I like boring. You should do a lot more.